So what if it's not a right triangle? We have this guy. We've done pretty good with it. But now, let's deal with these one right here, the oblique triangles. Oblique triangles have no angles that are 90 degrees. I mean, technically everything we're about to learn will work for right triangles as well. It just, the reverse doesn't. So please remember this. Everything we've learned so far, all of our current equations are only for right triangles. Everything we're about to learn is good for all triangles. Okay, it's good for all triangles, but everything we learned before this point, our trig identities, as well as Pythagorean theorem, only work for right triangles. So let's figure out what the first tool we're going to have is. The first tool is what's called law of sines. So here's my oblique triangle. Now we're dealing with things that don't have 90 degrees as one of their angles. At least we're assuming they don't have one. It could happen, but this works for any triangle. None of our previous equations will work. Luckily, mathematicians have done us a solid and figure out how to deal with this. The first new equation is called the law of sines. Remember, it works for any triangle, whether it's right or oblique. And it's connected, as we would guess, to our sine function. And it uses ratios to help us solve problems. How does it work? Well, it simply states that the length of side A over sine of angle A is equal to the length of side B over sine of angle B, which is equal to the length of side C over the sine of angle C. I love this one because it's really easy to remember. It's just the side over sine of the angle equals the side over the sine of the angle. So as long as I know 3 of these, I can solve. It can be pretty much anything. The only thing it can't be, because I can't solve that, is if I just know the angles. That one doesn't actually let you solve it. If you know the sides, you're still fine. So let's go from here. Let's try it out. So here's our triangle. Our first question says, if A is equal to 5 feet, A is equal to 30 degrees, and B is equal to 3 feet, what is B, C, and C? Woo! Lots of stuff to do. Let's get to it. So this is 30 degrees. This is 5. Okay. And this one is 3. I want to go ahead and write out my law of sines. So 5 over sine of 30, because I know all the stuff for A, is equal to B, which is 3 over sine of B. I don't know what B is, which is equal to C over sine of C. I don't know anything about that guy. Okay, well, let's see what we can solve here and see if we can get these guys done. I'm going to go for angle B first, because that one looks pretty easy. So I'm going to just focus on this part of the equation, and let's set it up. I need to get sine B by itself, so what am I going to do? I'm going to multiply both sides by sine of B. So I'll have 5 times sine of B over sine of 30 is equal to 3. As a note, if you wanted to, you could just plug this and turn it into a number. I'm not doing that. I'm just going to do the full algebra and then plug in my calculator at the end. But you can do it however you feel comfortable. Now I'm going to divide both sides by 5. And so I get that sine of B over sine of 30 is equal to 3/5. And I'm going to multiply both sides by sine of 30. And so that's what I get. And that equals 0.3. So sine of B is equal to 0.3. How did I know that? Sine of 30 is equal to a half. I just did it in my head. Now let's plug it into our calculator and figure out what that angle B actually is. So shift sine of 0.3. Okay, so I'm just doing sine to negative first of 0.3. It says it's equal to 17.4 degrees. Okay, that's cool. So I'm going to go ahead and write down my triangle here. I got it. Now let's see if we can solve for either one of these. What you're going to realize is that algebraically we can't. Like, even though I know this angle right now, I can't solve because I don't know either one of these. But I know something about triangles. I know that all three of these angles, A plus B plus C, is equal to 180 degrees. That's the case for any triangle, right or oblique. And so since I know that, I can solve. So what I get then is that 30 plus 17.4 plus C is equal to 180 degrees. And so 180 divided by, or 180 minus 47.4 is 132.6. So this angle right here is 132.6. Okay. Now I can solve for this guy. So I'm going to write it down. I'm going to still use my first kind of way I set up earlier. So 5 over sine of 30 is equal to C over sine of 132.6. I'm going to multiply both sides by this bottom part. And that gives me C. So C would come out to be equal to, let's see what it is, sine of 132.6 times 5. Very careful as I'm writing this my calculator. Sine of 30. And I get that it is equal to 7.36. Happy days. So these might take a little bit longer, but the practice is totally worth it. Okay, we erase all the ink on the slide, and we're going to keep on going. So now it says is B is equal to 2.8 feet. Okay, 2.8 feet. A is equal to 30. Okay. C is 75. What is A, B, and C? Okay, so still got a lot of stuff here. First thing I'm going to do is going to use the fact that I know there's 180 degrees in a triangle to solve for this angle B. So 30 plus 75 plus B is equal to 180. Therefore, B is equal to 75. How do I do that? That's 105 right there. 180 minus 105 is 75. Okay. Now, the second thing I'm going to do, just to make my life a little bit simpler, is to realize this is what's called an isosceles triangle. If the angles are the same, then their opposite sides are also the same. So since this one's 75 and this one's 75, that means that C is going to be 2.82. But what is A? What is A going to be? Well, we have to use law of sines to get that one. Some of the stuff we can do a little easier, but that one we're going to have to deal with old-fashioned way. So A over sine of 30 is equal to 2.8 over sine of 75. Pen is slowing down a bit. Who's getting tired? And if I plug that into my calculator, I get that A is going to be equal to, what is it? Let's find out. So 2.8 times sine of 30, because I'm bringing that over, divided by sine of 75. I get that A is 1.449. Now, does that make sense? As a note, if your angle is smaller, your side should also be smaller. So bigger angle, bigger number. Smaller angle, smaller number. It checks out. It makes sense. It's just something you can use to check yourself before you wreck yourself. Ew, that's so stupid. Okay, let's keep going. If C is 7 feet, B is 25 degrees, and A is 75 degrees, what is A, B, and C? My goodness, they're making us do so much. I say by they, it's me. I'm the one who made this. So B is equal to 25. Okay. A is 75. And we don't know anything else. What we do know is that A plus B plus C is equal to 180. And so that means that 75 plus 25 plus C is equal to 180. So C, the angle, is equal to 80 degrees. There we go. We got it. C equals at 80. So now I can use law of sines to solve for the rest. So A over sine of 75 is equal to b over sine of 25, which is equal to c, which is 7, over sine of 80. Is there too much practicing? No. No, there's not too much practicing. It is important that you practice, because if you don't practice, you will not learn how to do this. So we'll do a first. Why? Because why not? So I'm going to multiply both sides by sine of 75. And so I'll get that a is equal to 7 sine of 75 over sine of 80. And also similarly, I'll get that b is equal to 7 sine of 25 over sine of 80. Okay, so now if I plug this in my calculator, what do I get? Let's see here. 7 sine of 75 divided by sine of 80. And I'll tell you this, if the angles are really close to each other, this value is going to be very, very close to 7. Or very, very close to whatever this is. And this comes out to be 6.865. One, not nearly as close, sine of 25. Let's fix that a little bit. Okay, and this one comes out to be 3. Oh wow, almost exactly 3. Nice. Okay. So we got those values, I'm going to write them down. 3 and 6.865. There we go. That's another one done. Let's keep on powering through this. I'm just leaving this here in case it tricks me and says it's going to ask me about this one. It did. Okay. Should have just cleared the entire board. Well, I can do that now. Okay, so if a is equal to 30 degrees, got that one right there. B is equal to 25 degrees. What is A, B, C, and C? Now here's the problem. So I can find angle C. That's not a problem at all. A, B, and C. So let me see here. I've got 30 plus 25 plus C is equal to 180. So 55 plus C is equal to 180. So C is equal to 125. I've got it. Now I'm going to draw the triangle again. We'll draw the same triangle. Using the information I have no way to tell what size the triangle is because I don't know any of the sides. If you don't know any of the lengths of the sides, you can't solve these problems because while you might be able to find the angles, the scale of the triangle is unknowable. It's unsolvable. So this problem you can't actually do. I could have been mean and said, hey, try this one out. I did not though. I was not mean to you. Remember that. So, has no solution for that one. Okay, let's do one more question right here. Let's see if we can solve this one. So A is equal to 3 feet, B is equal to 2.5 feet, and C is equal to 4. Okay, not too bad. I've got most of my stuff here. Now, I don't have my trig identity, but let's use law of sines to solve for this. So I have 3 over sine of A is equal to 2.5 over sine of B, which is equal to 4 over sine of C. Issue here is this one is also unsolvable, but only with the law of sines. So we need to introduce a new tool to be able to solve these kinds of problems. So next time we're going to be moving into that. It is called the law of cosines. But hopefully this gave you some practice with using the law of sines. Thank you for paying attention. I'll see you all next time. Bye-bye.